Hi, my name is Cindy.
My name is Hailey. Today we're going to talk about the problem of finding the maximum and minimum of a function. Concepts that are involved in the questions are the definition of first and second derivative.
In this problem, we're given the expression of the function f at x equals to 2x cubed minus 30x squared plus 126x plus 16. The problem is asking us to find the minimum value of f at x on the interval of x greater or equal to 1 and smaller or equal to 5.
Some common mistakes students might make in solving similar questions are: first, misidentifying the minimum value for the maximum value or vice versa. 2. Forget to compare the value of the function at critical points with the value of the function at endpoints, therefore missing the actual minimum or maximum value. 3. Including solutions that are outside of the given interval.
Here are the steps for problem-solving process. Find the equation for the first derivative of the function and set it to be 0. As we learned in previous lectures, the first derivative of a function is an expression which tells us about the slope of a tangent line to the curve at any instant. If it is positive, the function is increasing, and if it is negative, the function is decreasing. When the first derivative equals to 0, the function is either at its local maximum or minimum, as the tangent line would be horizontal at that point.
After getting the solutions, check if it is within the given interval. As we learned in lectures, second derivative tells us the concavity of the graph of a function. If the second derivative is positive at a critical point, the graph concaves up and the critical point is the local minima. If the second derivative is negative at a critical point, the graph concaves down and the critical point is a local maximum.
Then, we compare the value of f at x at the critical point with the values at the endpoints. The critical point is the maximum or minimum value over that interval if it is the largest or smallest. However, if one of the endpoints have a larger or smaller value, then the maximum or minimum value would be that endpoint.
Now we can apply the strategies to our problem. First, we need to take the first derivative of the function and calculate the critical points. F prime x equals to 6x squared minus 60x plus 126, and for critical points we get x equals to 7 and x equals to 3. Because 7 is greater than 5, we should discard this critical point. X equals to 3 is within the interval and we should keep it.
Now, we take the second derivative of the function. By substituting critical point x equals to 3 into the equation, we find that it equals to negative 24, which is less than 0, such that it's a local maximum. Then we compare the value at both endpoints, and then we get the conclusion that the minimum value of f at x on the interval 1 to 5 is 114 at x equals to 1.
Hope you guys enjoyed this video and learned how to solve similar questions. Thank you. Bye-bye.
Thank you.